Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. So we are continuing our series on making a combat system, and we have the display that we spoke about in the last video. So if we mouse over these, we should see the details, and we're ready to start the actual combat. It says that our enemies will get to strike first, and so let's just go through a round of that. So, as you can see, fairly straightforward. All of the enemies have attacked in order, mostly missed and some of them hit. And since they've all sort of had their go, it's now our turn. But we're going to discuss only making the enemies attack in this particular video, and we're going to look at our turn next time. So let's look at the code that made that possible. Now you can see that compared to last video, we have several new pages, and we're going to mostly go through those. But let's go through the attributes. There's only the variables. There's only really one new variable that is relevant to this video, and that is $CS, which is a one-dimensional array. Stands for combat strategy, and it determines what the enemies are going to do. And it's just set up with a number for each of the 6 enemies. So, and that's 0, 0, 0, 0, 1, 2. So most of them have 0. A couple of them have something different. 0 just means that they strike at a random player character. 1 means that they will always attack the enemy with the lowest armor class, i.e. the enemy that's going to be easiest to hit. 2 means that they will attack the enemy with the lowest hit points. And in both of those cases, if there's a tie, if there's 2 characters that have the equal lowest of whatever stat they look at, then they just choose randomly between those 2 or more. A word of warning: this can be quite deadly. It's surprising how much. In this particular case, they mostly missed, so it wasn't that obvious. But often, just having them focus their attack on the one character can really doom that character. So if you want to use this in your own games, maybe be a bit sparing about it. The other thing I wanted to say was that the information that I've chosen to reveal on the mouse over, you could quibble with it. Why do you like? What's the in-game explanation for why you know what their attack bonus is going to be? You could say, well, you know their armor class because you can sort of look at them and see what armor they're wearing, and you know their hit points because you can see how sort of big and fit they are, or something like that. But then, would you really know their attack bonus until they started fighting? And conversely, why don't you know their combat strategy? Why don't you know that one of them is going to do this, and one of them's going to do this, and the others are going to do that? Well, it is pretty arbitrary. I just chose, for the purposes of an example, to give most of the information. Perhaps I thought that the more information you have, the more informed a choice you can make, and therefore the more skillful the game is, the less random the game is. So maybe I put that over realism. But of course, you may choose differently. You could set it up so that you, for example, know their attack bonus, but only after they've had an attack, and the explanation for that might be, well, you can see how they fight and you can see how good they are. You might put it that you only know what range of damage they do once they've hit successfully, for example, and you could justify that in game. You can easily see how that would make sense in game. You might have access to that information as a feature of particular classes. So you might say, well, if you're a marshal or something, that gives you the ability to know what attack bonus the enemies have, because you can sort of size them up and see what sort of quality of fighter they are, or something like that. You could have a spell that reveals this information, and have it that if that spell isn't cast, then you don't know how many hit points they have left, but there's some sort of magic that can intuit how how fit they are, or something like that. But I've gone with a simple, basic sort of version where you get most of the information sort of for free, and you can build on that if you want to. If it feels unrealistic to you, or you want to give advantages to specific types of characters. Anyway, let's have a look at the code. Having said all that, let's have a look at the code. I'll just zoom out a little bit. There we go. All right. So as I say, we've got several new pages. I have cheated a little bit because I wanted to show the enemies attacking. I just set it up. I changed the code so that it says set. Sorry, I highlighted the wrong one there. Set $AT equal to 1. In other words, set it up so that the enemies get the first attack. And normally that would be random, as it was in the previous video, so it would be random bracket 0, 1 end bracket, so that both sides have a equal chance of getting initiative. But that was just a cheat to be able to, for the purposes of the demonstration. Sorry, there is one more variable, and that is $CA, which is current attacker, and that is which character has the next go at attacking. And of course, it starts at 1 by default. It starts at sort of enemy number 1 and goes through all the different enemies. So let's have a look at how it works. The first thing we need to do, which of course we didn't need to do when it was a single monster and a single player character, is we need to choose which character they're going to try to attack. And we do this using the T array, $T, which is another new variable. Sorry, I forgot that one as well. Where is it? There it is. So $T is an array which is used for every individual blow, and it sets a value for each of the player characters, which is 1 or 0, and 1 means this is a possible target, and 0 means it is not a possible target. And it works fairly simply, based on $CS square bracket, $CA end square bracket. In other words, on the combat strategy followed by the enemy that is currently attacking. If that is equal to 0, then we just set the relevant slot in the T array to 1 for every every player character that has 1 or more hit points. In other words, every player character that is alive. Because of course it doesn't make sense to have the enemies trying to hit a dead character. But otherwise, everyone else is a possible target. So we have a for loop, and it just says if the relevant hit points, current hit points, is above 0, then yep, they're a possible target. And if not, of course, if they're dead, then they're not a possible target. If the combat strategy is 1, which is the lowest armor class, things are a bit more complicated. We set $Z to 20, $Z being a temporary variable. We have a for loop that goes through each character. If that character's hit points are greater than 0, then we set Z to the lower of its current value, or $A, $0, Y, $A being the array that stores armor class. So in other words, once we've gone through every character, Z will have the value of the lowest armor class out of the player characters that are still alive. And then we go through every character again, and if their hit points are greater than 0 and their armor class is equal to that lowest value, then we set their slot in T to 1, and otherwise we set it to 0. In other words, the T array will be set to 1 only for those characters that have characters that have the lowest armor class out of the player characters. Otherwise, because there's currently only 3 possible strategies, choosing the PC player character with the lowest current hit points, this works very, very similarly. We set Z to 100. The reason they're set to 20 and 100 is just that's a number that's above any character's value. Every character is going to have an armor class of less than 20, and every character is going to have hit points of less than 100. If that wasn't the case, if you were working with big totals of hit points, you might have to set this to 1,000 or 10,000. I've set it to 100 because I'm sort of operating on a scale where PCs might have sort of 10 or 12 or 15 hit points, but they're never going to have 100. So we go through. If a given player character's hit points are greater than 0, in other words, if they're still alive, we set Z to the lower of its current value or their current hit points. So it's exactly the same, except we're using hit points instead of armor in this line. And then we go through, and T is set to 1 for all characters whose hit points are exactly that Z value, i.e. the lowest hit points of any living character, and set to 0 otherwise. So in other words, we will have T set up so that valid targets have a value in T of 1 and others have a value of 0, and then we go to target. And in target, we choose a random player character between 1 and $C, which is the number of characters. And if TZ is equal to 0, then we include target, which is to say we go back to the top of the page and try again. Or we include strike, which is to say we continue in this process. So in other words, we're picking a character whose T value is set to 1, and if there's only one such character, it'll just keep randomly choosing until it finds that one character, or if there's more than one such character, it will choose randomly between those valid characters. Then we go to strike. Now this is basically the same as it was before, which is that so I won't go into this in too much detail. We roll a d20 virtually, generate a random number from 1 to 20, and add the relevant $B, which is attack bonus, and then if that total is over or equal to the armor class of the target character, which is stored in Z, then there's a hit and we generate damage. And if that is not the case, then then it's a miss. The only real addition in this case is that if we get a hit, and if that hit kills its target, then we add a little message that says so. So it'll be something like enemy 3 hits She is Brave for 5 damage, slaying them. And then we go to Next Attacker. Next Attacker simply adds 1 to $CA, which you'll remember is current attacker, and then there are various possibilities, one of which is that CA is greater than $E, i.e. the number of enemies, and the enemies are currently attacking. Well, what that would mean is that all of the enemies have had a go, and therefore it's the player character's turn. So in that case, we set CA back to 1. We set $AT, which side is attacking, to 0, meaning it's the player character's turn to attack. And then we set $DE to 1, which means it's the enemy's turn to defend. And we add to $M, which is the message that we're going to print next time we display the state of the combat. We add this message that says you have the initiative, and then we go back to display, which is the page that prints everything out for the player. So that's the case if the current attacker is greater than the value of $E and $AT is equal to 1, which means if the enemies are attacking but they've all had a go. Now the corresponding possibility is that $CA is greater than $C, which is the number of player characters, and $AT is equal to 0. In other words, the player characters have had their attacks, or it's the player character's turn to attack, but they've all had an attack. In that case, of course, we set CA to 1, we set $AT to 1, we set $DE to 0, and we add to the current message that your foes have the initiative, and we go to display. So those two are the possibilities of if the side that's attacking has had its go, everyone's had an attack. Otherwise, what if the hit points of the current attacker are less than 1? In other words, what if we've said, right, it's enemy 3's go, but enemy 3 is actually dead? Well, of course, we skip them. You don't get to attack if you're dead. So we just include next attacker. In other words, we go back to the top of this page and we'll just add 1 to $CA again so as to skip them. And if none of those special cases are true, which will usually be the case, then we just go straight back to display. And in display, I should have said this before, but anyway, I'll say it now. We have in the middle of that, we have one bit of code which prints where the enemies are at. We have a bit of code in the middle that prints $M, which is the message, the last thing that's happened. And then we have a bit of code down the bottom which is printing the player characters. Well, in the middle bit that does the $M, we print the message, then we print a line break, which is what that less than BR greater than is. And then we have a link for the player to click once they've read the message. And if $AT is equal to 0, which means if the player characters are now attacking, then that link sends them to the page PC, which, as you can see, is currently blank, which is the page that deals with the player characters attacking. Otherwise, it's the monsters attacking, and we click and we continue to enemy, which is the one we saw before, where we're assigning which player characters are possible targets. The only other thing I want to tell you is that I made a slight change to the layout, which is this here. Instead of just printing M, which is what I did, I did a table, but it's a table with only one row, and that row has only one cell in it. So why would you do that? You might ask, why not just print the text? Well, the reason was so I could do this. I put table, or less than, table style equals, quote, height, colon, space, 120px, which is to say 120 pixels. The reason for that is because sometimes the message that's printed has 2 lines. It says enemy 3 strikes at such and such but misses. And then it'll have your you now have the initiative, and then it'll have continue. So that's 3 lines, and sometimes, most of the time, it'll have 2. So something like you strike at enemy 4 but miss, or something, and then continue. And if it's by default, if you print 3 lines, that takes up more space than printing 2 lines, and as a result, the bottom part of this page, which is the 4 pictures of the player characters, will sort of move up and down slightly depending on what message is displayed. And I didn't want that to happen. I wanted to have the message in the middle taking up a set amount of space so that everything looked the same from one display of the screen to the next. And so what this does is it ensures that the cell that has the message in it will be exactly 120 pixels. I don't know if that's, overly fussy. I don't know if people would notice if I hadn't done that necessarily, but anyway, that's a layout thing, and that's what I did. So that is converting, or that is the enemy attacking side of group combat. In the next video, of course, we'll be dealing with the other possibility, which is that the player character is attacking, and that has some slightly different requirements, or some extra requirements from when it was a single combat. So I hope you found what I did useful or interesting, and I hope that you will tune in next time.